hopefully, while this video was already playing for about 8 minutes or so, you were getting the note page that looks like this. GCF, difference of squares. A bunch of words I know you've seen before. Now that's a new one. And of course, this is a new one. That's an old one. And you didn't get this piece of paper yet. That's a new one. That's my favorite method of factoring. We'll probably look at this on Monday, because tomorrow it's just like a 20-something minute class. So we're going to go over the homework that I'm going to give you tonight, and then that'll give us enough time to go over the homework, and then it'll be low key for the rest of the day on Friday. So pay attention, okay? We're going to just step through a few of these. I'm not going to do every one of them. It's kind of pointless to do every one of them, especially the ones you've learned before. So let's get started with those, okay? Again, just to kind of mix it up, we'll just go down the right side today. So I'm going to do number 2 and 4, okay? Ready? Remember, we're just pulling out a greatest common factor. That's GCF. That's what we've talked about again and again. The only reason we're kind of bringing this back up is because now we're not only talking about quadratics. Okay, we're going to be doing factoring with other type of polynomials, and therefore you need to remember that when you're factoring any type of polynomial, you always need to start with greatest common factor. So my greatest common factor, as far as numerically goes, between 14 and 7 is 7. Now, from a variable standpoint, look at this. This has m to the 8th. This has m squared. What's the most they both have in common? M squared. This one has n to the 5th. This one has n squared. So n squared. So my GCF is 7, m squared, n squared. So we're going to factor those out of both of these two terms. So let's start with this one. 14 divided by 7 is 2. M to the 8th divided by m squared is m to the 6th. Remember, you subtract. N to the 5th divided by n squared is n to the 3rd. And that's done. Now we move over here. Negative 7 divided by 7 is negative 1. M squared divided by m squared cancels. N squared divided by n squared cancels. So I'm left simply with 2m to the 6 n cubed minus 1. Okay? And that's it. That's all you have to do for GCF. So let's look at this next one. 16, 12, and 32. So I always start with this one, 12, and I go through the factors. 12 definitely won't go into 16. 6 also will not. 4. Will 4 go into 16? Absolutely. Will 4 go into 32? For sure. So my greatest common factor numerically is a 4. Now look at this. This one has x to the 3rd. This one has x squared. This one just has x. All I can take out is an x. This has y. This has y squared. This has y cubed. All I can take out is a y. So my greatest common factor is 4xy. So let's see what it leaves me with. 16 divided by 4, 4. X cubed divided by x to the 1st is x squared. And y divided by y will cancel. Moving along. Negative 12 divided by 4, negative 3. X squared divided by x is just x. Y squared divided by y is just y, so negative 3xy. And then finally, positive 32 divided by 4 is positive 8. X divided by x cancels, and y cubed divided by y to the 1st is y squared. So there we have GCF, greatest common factors. This is something that you've been doing. You should be comfortable and familiar with it. Now, let's move along to perfect squares and difference of squares. Remember, your perfect squares are numbers that you get when you multiply something by itself. So like 1 times 1, 1, perfect square. 2 times 2, 4. 3 times 3, 9. 16, 25, 36, 49, 64, 81, 100. We've talked about these and more. So we've talked recently about difference of squares. Okay, remember the rule? If these are both perfect squares and the sign in between is a minus, we can factor this binomial into two binomials. Remember that? It's the only time you can factor a binomial into two binomials. So that rule is, what will multiply by itself to get a squared? That's a. What will multiply by itself to get b squared? That's b. And hopefully you guys recall, the rule is one's a plus, one's a minus. Remember this? Easy stuff. So that's what we're going to continue to implement. I'm not going to spend a lot of time on this again because we've done it. So don't forget, when I look at a problem like number 6, don't forget to check to see if it has a greatest common factor. You see, this one does not. Nothing will come out of 9 and 49. So then I look at it and I see these exponents are squares. They're multiples of 2. So the only thing that it might be is difference of perfect squares. I just got to remember, is 9 a perfect square? Absolutely. Is 49? Yes. So this is difference of perfect squares. So it will factor into two binomials. What multiplies by itself to get 9x squared? Well, that's 3x times 3x. What multiplies by itself to get 49y squared? Well, that's 7y and 7y. And what's the rule? One's positive, one's negative. Done. Okay, easy stuff, right? Hopefully you guys recall this. Look at the next one. Again, I can immediately look at this thing and say, hey, c to the 4th is a multiple of 2, so it could be a perfect square. But 72 is not a perfect square. 2 is not a perfect square. So hopefully right off the bat you guys realize that's a GCF. You can pull out a 2. If you pull out a 2, 72 divided by 2 is 36 c to the 4th. And negative 2 divided by 2 is negative 1. Now we have difference of squares. Now it will factor into two binomials. What multiplies by itself to get 36c to the 4th? 6c squared. What multiplies by itself to get 1? 1. And what's the rule? Positive, negative, done. Okay? I'll show you this one real quick. Take out a 10w. That leaves me with w to the 4th minus 1. So again, that's the difference of two perfect squares. What are they? W squared, 1 and 1, plus and minus. Now, the reason I wanted to show you this one real quick is because now that we're dealing with bigger polynomials, sometimes like this, I'll factor it, and then I'll recognize that something else could be factored again. Notice, right here, that's difference of two perfect squares. So I factored difference of squares only to get one of these to be difference of squares again. So I'm going to bring down the 10w. I'm going to bring down the w squared plus 1. But remember, I can factor difference of squares into two binomials. What multiplies by itself to get w squared? W. What multiplies by itself to get 1? 1. What's the rule? One's positive, one's negative. Now it's been completely factored. Okay? So a little challenge there, okay? You do something only to realize it can be done even more. So you kind of got to be on your toes with these different polynomials that we can factor. So just be aware, okay? Now that brings us, and we're 17 minutes into this video, so we're doing really, really good. But that brings us to the last two that we have not talked about yet. You haven't learned these because we've only dealt with factoring quadratics. Well, this is not a quadratic, is it? When your biggest exponent's cubed, it's not a quadratic. It's a what? Cubic. So we're factoring these using a different method. So listen, it's the one time a binomial will factor into a binomial times a trinomial. It's the one time a binomial will factor into a binomial times a trinomial. Now, don't forget what some of your perfect cubes are. And again, you're probably not as familiar with these as you are other values. Perfect cubes you don't use as much. Sorry, I had to walk away from my computer for a moment just to get my note sheet, because even for me, perfect cubes are not something we use quite as much. So perfect cubes are when you multiply something by itself 3 times. So most of them are pretty familiar, okay? Like 1 times 1 times 1, that's 1. 2 times 2, and I didn't find my sheet, so if I screw this up, that'll be on me. 2 times 2 times 2 is 8. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125. 6 cubed, 216. 7 cubed, 343. 8 cubed, 512. 9 cubed, 729. Up to 10 cubed, 1,000. As you can see, these get big real fast. Now, if I miss one of these, please don't make fun of me, because I just kind of forgot. And I forgot my paper, can't find it real quick on the spot. So I think that's them. Anyways, let's move along to the rule. Remember, I told you it's the one time a binomial will factor into a binomial times a trinomial. So that's the first thing I want you to write. It's a binomial size times a trinomial size. Now here's how it works. What multiplies by itself to get a cubed 3 times? Well, it's just a. So whatever that value is that's being multiplied, like for example for 125. If 125 was that perfect cube, well, what is the number that multiplies by itself 3 times to get it? It'd be 5. 5 would go right here, okay? And then, of course, in this other spot, you've got the number that multiplies by itself 3 times to get b cubed. So that's going to be b. So your binomial is made up of a and b. Now, let's go to your trinomial. I like to start with the edges. The edges, you take a and b and you square them. So this edge will be a squared, and this edge will be b squared. Okay? So the last term that I need is this middle term. To find this middle term, you simply multiply a times b. So there's your binomial and your trinomial. Now, obviously, you guys can see I've left out signs. I personally like to leave out signs until the end because there's a basically kind of like a formula, if you will. See, if the original binomial was plus, then your binomial here has to be a plus. But to offset this, because think about it, guys. If I do 2 times 3, I'm multiplying 6 times. 6 times. 6. But the result is only 2 terms. How could I multiply 6 times and have only 2 terms escape? Well, the reason is because if this is positive, this sign is negative, and what happens is those things offset each other where they cancel each other out. Now that leaves our last term here, b squared. Well, it's always positive, always. So there it is. That's how you factor sum of cubes. Okay, it's real simple. All right, watch, and we'll just keep going down the right side. 8w cubed plus 1. Again, is 8w cubed a perfect cube? Well, w cubed definitely is. It's a multiple of 3. If it's a multiple of 3 as a variable, it's a perfect cube. But 8, it's on my list, right? That's 2 times 2 times 2. So is 1. So this will definitely factor into a binomial times a trinomial. So what are they? Well, it's 2w, right? And it's 1. So there's my binomial. So let's go to our trinomial. Our first term in our trinomial is my a value, 2w squared. Well, what is 2w times 2w? 4w squared. The other end is b squared. Well, that's 1 squared, which is just 1. And then how did I say we find that middle term? A times b. That's 2w times 1, which is 2w. And then again, I like to hold off on the last minute. If this is plus, and that offsets it as a minus. And this is always a plus. And that's it. That's all there is to factoring sum of cubes. It's really quite simple. Okay? Now, again, please don't forget, like on a problem like number 14, don't forget to check to see if they have a GCF. 343 and 64 actually don't. And I want you to notice, see how this P is cubed and this Q is cubed? Those are multiples of 3. It has to be sum of cubes. So here we go. Binomial times a trinomial. Ready? What multiplies by itself 3 times to get 343 P cubed? That's 7P. What multiplies by itself 3 times to get 64 cubed? Well, that's 4 cubed. 4 cubed. So that takes care of these two, the binomial. Now, we're going to square those and put them on the ends. What is 7p times 7p? 49p squared. What's 4q times 4q? Well, that's 16q squared. And then what did we say we do in the middle? A times b. That's 7p times 4q. That's 28pq. And then again, last step, there's a plus sign, minus sign. And this is always plus sign. Easy, right? Easy as can be. All right, now, if you look at this one, I want you to notice that there are some variables they share, but also 24 and 375 are both divisible by 3. So I'm going to pull out a GCF of 3. Now look, this has c to the 4th. This has just c. So I can pull out a c. This has d, but this has d to the 4th. I can pull out a d. So let's see what this leaves me with. 24 divided by 3 is 8. C to the 4th divided by c is c cubed. And d divided by d cancels. In the next one, 375 divided by 3 is 125. C divided by c cancels. And d to the 4th divided by d to the 1st is d cubed. So sure enough, all of a sudden, I turn this into sum of perfect cubes. See, multiples of 3. 8 is on that list. 125 is on that list. So I'm going to bring the 3CD on down, but this is going to factor into a binomial times a trinomial. So here we go. What multiplies by itself 3 times to get 8c cubed? 2c. What multiplies by itself 3 times to get 125d cubed? 5d. We're going to square those. 2c times 2c, 4c squared. 5d times 5d, 25d squared. And then in the middle, let's multiply them. 2c times 5d is 10cd. Last thing, if this original sign was plus, this is a plus, this is a minus, this is always a plus. And there it is, guys. That's how you factor sum of cubes. Now, it would be great for y'all in y'all's brain if we could go to the next type and it really not be much different. Well, guess what? It's not. In fact, it's very, very much the same. It still factors into a binomial times a trinomial. Our factors still include a and b in my binomial. They still include a squared and b squared on the ends of our trinomial. And it still involves a, b in the middle. Everything's identical. What do you think is going to be different? You're probably guessing it. This is what's different. Because the original one is minus, your binomial here has to be minus, and to offset that, this has to be plus. That's it. That's the only change. Remember, b squared, it's always positive. You can't make b squared not positive. These are the ones that are interchangeable. Look, they're identical, except when this is plus, that's plus, and that offsets it as minus. And when that's minus, this is minus, and that offsets it as plus. So this makes it so easy for me. I don't have to really think. I can just kind of react. Look at 64 minus w cubed. Definitely difference of 2 cubes. Look, multiple of 3. And 64 is on my list above. So binomial times a trinomial. Watch how fast I can do this. What multiplies 3 times to get 64? 4. What multiplies 3 times to get w cubed? W. Square 4, square w, multiply 4 and w. If that's a minus, so is this, and that offsets it. This never can. It's always positive. And that's how fast you can do this, guys. Okay? So let me show you one more, number 22. Because these are not different, these are not perfect cubes. 2 and 54, go look. They're not on that list we wrote down. And I think that list is pretty much right. I don't think I made any mistakes. But don't forget, you can still pull out a GCF. That leaves me with x cubed minus 27y cubed. And that can be factored using difference of cubes. X, 3y, square x, square 3y, right? 3y times 3y, 9y squared. And then multiply x times 3y. That's 3xy. If this is a minus, so is that, and this has to offset it. That's always positive. So, no need to spend a great deal of time on this new rule. It's pretty simple. You just have to make sure you understand what distinguishes it from difference of squares. Remember, these have to be multiples of 2. Look, multiples of 2, multiples of 2, well, you have to pull out a GCF. After we pulled off GCF, multiples of 2. So your variables have to be multiples of 2, where in perfect cubes, they have to be multiples of 3. And it works for both sum and difference. Same rule, very, very slight differences. So here's your homework, guys. It's on this page that either is headed your way or will be coming your way now. It's numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 11 problems. Okay, you got about 15 minutes in class now because this recording is at 31 minutes. So 11 problems, and this is just writing the equations. So really it's just 8. Okay, you already know these rules. They go right here. So you're doing 8 problems. So use the time that you have in class. Enjoy having no homework if you get it done now. And I'll see you tomorrow.